everyone, I hope all of you are doing good, and I am back with the part 2 video of electric current and its effects, class 7 science. So in this video we are going to learn about electric circuits. Now, as part of our study on electric current, how do we draw electric circuits? What are the symbols that we use? What are the conventions that we follow? Now, this is going to be a very important one which will be useful for you even in your higher classes. So, it is important that you concentrate in this video. Let's get started. So now let us talk about some more important things. So everywhere till now I have been showing you a circuit where you see there is a switch, there is a battery and there is a bulb. As soon as the switch is on, the bulb glows. So the question is, when exactly the bulb glows? So you might say that when we switch, when we put the switch on. But what happens when we put the switch on? When the bulb glows when the circuit is complete. Now yet another mystery. What do I mean by circuit is complete? So let us have a look at the circuit. So this is how the circuit looks when the switch is off. So this is the switch. So right now the bulb is not glowing and the switch is off. What happens? As soon as we switch it on, the bulb glows. Now, do you understand something? What happens when we switched it on? Now, as soon as we switched it on, the circuit became complete. So, everywhere you can see this line. That means there is a path which is there for the electrons to flow. Now, only when the electrons will flow, there will be a current flowing through the circuit. Now, if the electrons stop flowing, what will happen? There will be no current. And if there is no current, the bulb will not glow. So, it is as simple as that. I was giving you the examples of balls, right? So, electrons are nothing but like those balls. So, the balls need to move. If the balls stop moving, there is no current. Now, when the switch is open, when the switch is off, in that case, there is a break in the path here. So, once the electron reaches here, they are not able to move further. So, as a result, all the electrons, they stop. They are not able to move. So, there is no current through the circuit and therefore the bulb doesn't glow. But when we switch it on, the circuit is complete and therefore the bulb glows. So now you might ask, what exactly is a circuit? How do we define a circuit? Because every time I am using the word circuit, electric circuit. So let's understand what a circuit is. But before that, let us look at this example which will help you to understand the meaning of a complete and an incomplete circuit. So in this picture, what you can see, there is a bridge and you can see a cyclist here. The picture of the cyclist is quite tiny, but I hope you are able to see it. So the cyclist is moving on this bridge, correct? How is the cyclist able to move here? Because there is a path for him over which he is able to cycle. Now let us say if the bridge is broken here, if somebody breaks the bridge here somehow, let's say. So do you think that the cyclist will be able to cross the bridge? No, because there is no path for him to move. So he will have to stop here. So the same thing happens here. When the circuit is complete, there is a path for the electrons to flow and therefore there is a current in the circuit. But when we break the circuit, then the circuit becomes incomplete and therefore the electrons can't flow and therefore there is no current. So now let's understand it in this way. So in your real life, what you can do is, you can try to make a simple circuit like this. Take a bulb, take few wires lying here and there in your house and take a battery. So even if you do not find all these in your house, but I am pretty sure that you will be able to find them all in your laboratory. So you will observe that when the bulb is connected to the battery, which is the source of electric current, and if the two ends of the wire are not linked to each other. So if they are not joined to each other, so if they are left free, the bulb doesn't glow. That's because the path is not complete. The circuit is not complete. So it is broken here. So the electrons cannot flow. There is no current. Therefore the bulb doesn't glow. But for the same circuit, when the free ends are joined, so when you join the two ends, now you have a complete path for current to flow. As a result, the bulb glows in this case. So this setup which you see on the screen, that is nothing but a circuit. So a circuit is basically an arrangement where you have different components, all of them are connected to each other. So that's how a circuit looks like. And this circuit provides a path for the electric charges to flow so that current can flow. So if we have to define electric circuit, we can say that it is nothing but a path for current to flow. It's quite simple. The path, the bridge which is needed for the cyclist. Similarly, the path which is needed for the current to flow. So that path is nothing but electric circuit. Now in the previous slide, you saw how exactly electric circuits are formed. Now when we want to represent electric circuits, because electric circuits are not always as simple as having one bulb, one battery and one switch. So they are not always that simple. So we have complex circuits which exist inside our refrigerators, inside the television sets, inside our computers. So we have very complicated circuits. So there has to be a way to represent these circuits, and that way is nothing but drawing a circuit diagram. So the circuit which we saw in the previous slide, the same circuit. So this is the circuit which we saw, where we actually have a bulb, we have a battery, and then we join the ends of the wires, and then you have a complete circuit where the bulb glows. But the same circuit can be represented by using a circuit diagram, where instead of drawing a bulb, because now if you start drawing each component of the circuit, that is going to be tedious. And also that will not be uniform. So now somebody might draw a bulb in one way, somebody else might draw it in some other way. So therefore we follow certain symbols of different parts of a circuit, and that's how, and with the help of all those symbols, we draw a circuit diagram. So let us see how a circuit diagram looks like. So it is a pictorial representation of an electric circuit. So advantages of having circuit diagram is that it is understandable by everyone, because here we make use of symbols, and the symbols have specific meanings. That is one thing. The second thing is it is more convenient. Now if I ask you to draw a real bulb, that is going to be more complex for you, because not everybody is very good at drawing. So that means it becomes more convenient. So it is drawn using the conventional symbols of different circuit elements. Now what are circuit elements? The various components which are present in a circuit. For example, the bulb, the battery, the switch. So these are all circuit elements. Now it is very important that we use the correct symbol for each of the elements. So let us look at the conventional circuit, the real circuit. This is how it looks. But when you draw a circuit diagram for the same circuit, this is how it would be. So where instead of the battery, you use this symbol, instead of the key, you use this symbol, and you have a bulb. Now let us quickly look at the symbols for a circuit diagram. So let us look at some of the important circuit elements. Like the first thing would be wire, because it helps to connect the different other elements. For example, the battery, the bulb, the switch. So all of them are connected through wires. Cell, another important thing, because cell is the source of electricity. So it generates electricity. Battery. What is battery? It is nothing but combination of cells. Now a cell has a particular limit of generation of electricity. So now when we need more current to be generated, there we need more cells. So we need more power basically. So at that point of time, a lot of cells are connected together to form a setup called battery. Another important thing is the switch. Now the switch, when it is an off condition and when it is an on condition. So for each of these we have specific symbols. So let us quickly look at the symbols which are used in circuit diagram. So for wire we just use a straight line, as you can see. For a cell we use two lines, two vertical lines. And we make sure that one line is longer than the other one. Now why do we have two lines of different lengths? That's because the longer line represents the positive terminal of the cell and the smaller line represents the negative terminal. Now it is very important to differentiate between the positive and the negative terminal of the cell. That's because when we talk about the flow of electric current, as I said, the conventional current, the direction will be from positive terminal towards the negative terminal. So that way it becomes important to know which one is which terminal. When it comes to battery, since it is combination of cells, therefore a lot of cells put together forms a battery. Now, one interesting thing that has to be noted here is that cells are connected together in such a way that negative terminal of one cell is connected to the positive terminal of the other cell. Now, why is the connection made in this way? That is because now when all of them are connected in like one after another, in that case we expect that the electric current which is generated out of each of these cells, they should sum up to give rise to a greater amount of current. So that is the purpose that these have been arranged in this way. Now in your higher classes, when you will learn about the internal functioning of the battery, I mean how exactly the charges flow from the positive towards the negative terminal, so then you will get to know that why we have this specific type of arrangement in a battery. When you talk about a switch, this is how it is represented when the switch is off. So when the switch is off, the circuit is broken and therefore current doesn't flow through the circuit, and this is how it is represented. Now a switch is often called as a key in a circuit. So key is another word which is used for switch. Now when the switch is off, this is the off mode of the switch. So this is also known as we also say that the key is open, because you can see the key is open here, and this circuit would be known as an open circuit because the circuit is not complete. Whereas when the switch is on, so you see the complete path is being created. So in this case we say that the key is closed. So like switch off is equivalent to open key and switch on is equivalent to closed key. So that's how it is. So these are the basic symbols and we need to remember these symbols in order to draw any circuit diagram. So let us look at a simple circuit diagram. So we are showing the same circuit diagram. Now that we know all the convention, you can see that initially this is the key and right now the key is in open state. Right? What is this? This is the cell, this is the positive terminal, this is the negative terminal. Now as soon as you switch it on, that is the key gets closed, so now you have a complete path for the current to flow. And the current will flow from the positive terminal towards the negative terminal of the battery. So this would be the direction of current. Now please note that while we draw a circuit diagram, we can place the key anywhere in the circuit. So it is not mandatory that the key has to be placed at this position only. So it can be placed anywhere. One important thing is that the cell should be drawn appropriately so that you do not end up drawing both the lines of equal size, because that will create a confusion. Because when you draw it like this, it basically becomes a capacitor. Now what is a capacitor? That you will learn in higher classes, but for now you should know that there is a big difference between these two. So whenever you are trying to represent a cell, make sure that the positive terminal is longer than the negative terminal. So now the next question which comes in front of us is, why does the bulb glow? We got to know when does the bulb glow. When we switch it on, the circuit is complete and the bulb glows. But when the circuit is complete, why the bulb is glowing? Will it glow in all the scenarios? We just need to provide a complete path, or we just need to provide a circuit? So here is another interesting thing. The bulb glows because current is allowed to flow through the wire of the circuit. Now this is the catch here. Allowed to flow. That means it is also possible that certain materials might not allow electrons to pass through them, might not allow current to flow through them. So we will again take the same example of the bridge. So in the last question, we saw that what happens when the bridge is broken. So if there is no path, obviously the cyclist will not be able to go. Now let us say that, okay, the bridge is not broken, the bridge is as it is. But let's say there is some strike because of which people cannot cross the bridge. So the bridge is there, the path is there, but it is not allowed to move on that bridge, or it is not allowed to cycle on that bridge. So in that case also, the cyclist will not be able to cross the bridge. But in this case, the circuit is closed, but still the bulb would not glow. So this means that there might be some materials which might not allow current to flow through them. Yes, exactly. So it is not necessary that all materials allow current to pass through them, and therefore in electric circuits we make use of such materials which allow current to flow through them. For example, normally we make use of wires, and these wires are made up of metals which allow current to pass through them. Copper wires which allow current to pass through them. So not only copper, most of the metals allow current to pass through them. So therefore, the nature of material of the wire is also an important factor which decides whether current can flow through the circuit or. So that was another part of the circuit. Now let us talk about the most important part of the circuit, that is the cell. So electric cell is that thing in the circuit which is the source of electric current. So it is the device that generates electricity. So without an electric cell, there will be no current at all, because there is nobody else who can generate electricity. Now when we talk about current flowing, what is current? Nothing but the flow of electrons. But from where are we getting those electrons? So those electrons are actually coming from the cell. So if there is no cell, obviously there is going to be no current. So cell is a very important part of the electric circuit. So when you try to perform this experiment, you take the bulb, you take a cell or a battery, and you join the entire circuit. So in this case, the bulb glows because the current is generated by the cell, and then that current flows through the entire complete circuit. Now when you look at how an electric cell generates electricity, you will see that, when you actually see the construction inside an electric cell, because from outside it just looks like a small cylindrical thing where you have a positive and a negative terminal mentioned. But if you actually look at the interior, the construction of an electric cell, you will see that it is constructed in such a way that a lot of chemical reactions are actually taking place inside, which causes the electrons to flow. So all these chemical reactions are responsible for the flow of the electric charges. So if you ever get a chance to learn more about the structure of electric cell, you will see that there are two electrodes. One is a positive electrode, another one is a negative electrode. And due to the presence of these two electrodes and the presence of a solution which is often termed as electrolyte. So you have a positive electrode, you have a negative electrode, and you have an electrolyte. So electrolyte is basically a solution which is present inside the cell. So these are the important parts as far as construction of an electric cell is considered. So this entire setup of electric cell facilitates the transformation of energy from one form to another. Basically, as I said, a lot of chemical reactions will be taking place inside, and then these chemical reactions, so basically the chemical energy which is stored inside the cell gets converted into electrical energy, and vice versa. So transformation of energy is one very important aspect of electric cell. Now we will not get into the working of electric cell. However, if you are interested to know more about it, you can refer the video lessons on physics for class 11th and 12th. So there you will see more and more detail on working of a cell. So that was cell. Now, why do we need battery? Because I said that battery is nothing but two or more cells joined together to form a battery. Now, when the need of our electricity is more, because I said that cell is nothing but the generator of electricity. Now, if we need more electricity, so in that case, one cell is just not enough. So in that case, we need more cells to combine together to generate more electricity. So let us take a small example. Let us suppose that you have a 10 rupee note. That's all you have, a 10 rupee note. And you want to buy a sandwich. Now when you go to the shopkeeper, he says that the cost of the sandwich is 50 rupees. But what do you have? Let's say this is you, and you have a 10 rupee note. You just have one 10 rupee note. Now you went to the shopkeeper to buy a sandwich, and the shopkeeper said that the price of the sandwich is 50 rupees. Now but you just have one 10 rupee note. So will that be enough to buy you a sandwich? No. But instead of 10 rupee note, instead of one 10 rupee note, if you have 5 notes of 10 rupees, so that will sum up to form 50 rupees, and this can buy you the sandwich, right? So the same thing is true here. So sometimes one cell is not sufficient to produce enough electricity. So in that case, multiple cells are grouped together to form a battery, and therefore a battery is capable of generating more amount of electricity. So look at this. Here we have two cells which are connected back to back to form a battery. Now a battery can be a combination of two cells. A battery can also be a combination of 4 cells. It can be more than 4 cells. So how we connect the cells to form a battery is that the positive terminal of one cell is connected to the negative terminal of the second cell, and so on. So let us say if this is the positive terminal and this is the negative terminal, this is positive, this is negative. So the negative of the first cell is connected to the positive of the next. Again, the negative of this one will be connected to the positive of the next cell, and so on. So that is why when you represent it in a circuit, this is how we represent it, which shows that positive, negative, positive, negative, positive, negative, and so on. So negative connect to positive, again negative connected to positive, and so on. So this is how we arrange multiple cells to form a battery. Now the question is, where do we use batteries? Now, have we ever seen batteries being used around us? Yes, in a lot of things. Torch, the most common example, and it is very easy to open the torch and see the batteries inside. So once you take the batteries out of the torch, does your torch work? No, because battery is the source of electricity. If there is no battery, there is no working of the torch. Look at the remote of your television. The remote also operates on a battery. So just if you want to have a look, just reverse the remote, and on the back side you will see that a symbol will be there which will show that the battery exists here. So once you open that panel, you will be able to see the battery. A lot of toys, a lot of musical toys or toys which move from one place to another, they also operate on batteries. In fact, the singing doll, dancing dolls which you have, they all operate on batteries. You also have the inverters in your houses or in your companies which provide you backup. When there is a power cut, your inverters are able to provide you backup. That's because inverter is again can generate electricity, so it can act as a backup. You look at the batteries in your car. So the batteries in your car, what are they? Again, they are the batteries. So basically batteries have huge number of applications. So you can actually see a lot of battery operated devices. And I hope you understand how important battery is, because it is able to generate electricity. And electricity can run a lot of appliances. Let us now talk about yet another interesting fact. I have been telling you that since current flows through the circuit, that is why the bulb glows. Now, what is it in the bulb that makes it glow? What is it that is glowing because of which we are able to get so much of light from the bulb? So, that important part of the bulb is the filament. So filament is actually a thin wire which glows when current passes through it. So just try to observe the bulb. So you will see a wire like this inside. So this wire is nothing but the filament, and this filament is made up of a material which when heated produces sufficient light. Now any metal needs to be heated sufficiently before it starts emitting visible light. Now, in that case, we just cannot use any metal to be used as filament of the bulb, because most of the metals, when you start heating them, they will melt after a certain point of time. So therefore, we need to choose a metal which has a very high melting point. So if it has a very high melting point, that means it will melt only at a very high temperature. Right? So therefore, the filament of the bulb is made up of a metal called tungsten, and which property of tungsten attracted it to form the filament of the bulb? Its very high melting point. However, there is a disadvantage also associated with tungsten, that it can catch fire very easily at such high temperature in presence of oxygen. So, it's like, since it is able to, it has been heated too much. So there are, if a little bit of oxygen is present, it will catch fire. And that is why this filament is sealed inside a chamber, and this chamber, a glass chamber which you see outside the bulb. So that is the glass chamber, and it is ensured that this chamber is free of oxygen, because if little bit of oxygen also reaches this chamber, then the filament will burst and it will catch fire. Right? So I hope this is clear, because this is something very interesting and important as well. So now whenever you look at a bulb, you know that what is that wire inside the bulb and why is it there, and what is that wire made of. It is actually the metal tungsten, which has a very high melting point. So even before it can reach that temperature where it starts melting, before that only it starts emitting visible light, and that's how the bulb emits light. Now, what happens in case of a fused bulb? I am sure now with the picture itself you are able to understand. Now, in a fused bulb, this filament breaks. So, due to the broken filament, even though the circuit is complete, so the current is flowing through the circuit, but when the current tries to flow through this filament of the bulb, the path is not complete. So therefore, the current is not able to flow, and as a result, the bulb doesn't glow. So a bulb is said to be fused when the filament is broken. So that is another important thing. So whenever the bulb in your house is not working, so before you call an electrician to check the electrical circuits of the house, first you need to check if the bulb is fine, if the filament of the bulb is proper, because many a times the bulb get fused. So in that case, you can change the bulb and then everything starts working fine.
I hope you found the video useful. If you have a feedback to share, do let us know in the comment section. If you really like the video, what are you supposed to do? You are definitely supposed to like as well as share the video. I will meet you all very soon with a new video with a new topic. Till then, take care. Bye-bye.